name is Rick Ziegler with the US EPA, but that's not important for this session. What's important is that it's a session on by IUCN on their red list of ecosystems. We're going to have Ms. Ruiz and Dr. Hessenbeger, but first, John Paul will take the stage.
So apparently the audience online is like higher than the audience in the room, which is it's not bad. There is almost 40 people joining online, and we are 10. But it's not bad. And we have David. You will see here in the screen we have David Keith, which is Professor David Keith, also working with the red list of ecosystem, and. So for the next 2 hours, we will be talking about the implementation and the application of the IUCN Red List of Ecosystem. And I would like to invite first John Paul Rodriguez. He is the chair of the IUCN Species Survival Commission. And as I said, also, we will have David Keith, our lead for the Red List of Ecosystem thematic group, and Dr. Daisy Hessenbeger, who is the Native Solution Support Officer for IUCN, the International Union for Conservation of Nature. And this is a short introduction about how the session will be structured. First, John Paul will be presenting the past, present, and future of the Red List of Ecosystem. Then we will pass through an overview. Then David Keith will be presenting the global ecosystem typology. And finally, we will talk about more which are the categories, the criteria of the Red List of Ecosystem, to then go through an assessment and to see which could be the potential application of this methodology. We will finish the session with an interactive session about the application.
Hello, everyone. Hello, David. Good to see you. Excellent. Well, it's wonderful to be here. Thank you all so much, and hello to all of you watching online. Wonderful you could make it. Well, what I'll do is I'll go through a very informal kind of a timeline of the Red List of Ecosystem, seen from my perspective as one of the people that was jointly with David Keith initiated the process within IUCN. It wasn't the first time that people spoke about the Red List of Ecosystems within IUCN. There were previous efforts, but I'll tell you the story of this last effort that started in the year 2000. My involvement, at least in the year 2000, in Amman at the World Conservation Congress. We had just finished the National Red List of plants. 5 years before, we had finished the National Red List of animals in Venezuela, where I'm from. And one of my colleagues said to me, well, you did plants, you did animals, do ecosystems. And I said to him, the problem is that IUCN hasn't developed a standard kind of system, categories and criteria, to apply. And he looked at me sort of skeptically and said, well, invent it. And that's how it all started, this iteration. David got involved early on in this process together with several dozen people. And after an initial few years of putting together some preliminary ideas, we went to the World Conservation Congress in Bangkok, where we had a motion, a resolution, asking the Union to develop a Red List of Ecosystems. The Commission on Ecosystem Management established the Red List of Ecosystems thematic group, and we started working on some initial proposal of categories and criteria that led to a paper that came out, very, very rough, conceptual, very heavily based on the Red List of Species and the same concepts. We put out a short document in Spanish, English, and French. Also was translated the abstract in Chinese, Bahasa, Indonesian, and Danish. So it was we started asking around, telling people about this, started a global consultation about the initial ideas, the initial thinking that led to a really widespread consultation around the world, where we had at least 20 countries involved, lots of workshops, small workshops and big workshops, a lot of showing people these ideas and testing them around the world. We initially established a focus on communication, established an initial website that were all the data that was being generated, all the documents, the case studies, the standards. We put them there, made them readily accessible for anyone to participate. That process continued, and it was refined, and more people were brought into the process. And a few years later, this paper came out, and in PLOS One, in the year 2013, which really was really the foundation, the establishment of the list of ecosystem categories and criteria. What we see now, what is available now, is a further refinement, but there was a major conceptual step that was taken, led by David, but with many other people involved as well. The appendix to this article, which is a series of case studies, has several hundred pages, 200 and something pages, if I remember correctly, just of testing out the red list of ecosystem criteria and all kinds of ecosystems, some threatened, some not, from all over the world. So it was really a process that took a few years, but was crystallized in that document. As you know, what the principle of the red list of ecosystem, the same thing as species, is that it classifies ecosystems according to the risk. We call it risk of collapse as the analog of risk of extinction, and you'll hear more about that from others during the day today. And oops, there's one slide. There it is. Then we started, after doing that, applying this at larger geographical scales and explored the application of these categories and criteria at the level of a continent. You can see there from the year 2012 to this year, that process has been ongoing. And the most recent results of that analysis, oops, there they are. The most recent results of the analysis is an article, a scientific paper that is now currently almost accepted for publication, very, very close, that summarizes the status of the terrestrial ecosystems of the Americas, from the northern part of North America to the southern part of South America. Here we present the results for forests, but we have the results for all terrestrial ecosystems. And we present the data to users at the continental level and at the national level. So it's a big step. We hope to continue expanding to other parts of the world. All the documents and the standards and the guidelines are available online. You can visit the website, which is a new version. There's a website address down there at the bottom. And there's a document that you can see there on the right of the screen, which are the guidelines for the application of the red list of ecosystems, categories, and criteria. It's not such a long document. It's a little bit smaller book, but it really has, imagine the article that I just showed you of PLOS One, but taken, built up a little bit more, and prepare for a wider audience with a lot more examples and better graphics and so on. So the process continues. In addition to terrestrial ecosystems, there are people who have explored application to marine ecosystems, freshwater ecosystems. We're expanding into other biological realms, and all over the world now. That map there shows more or less the status of the current progress of the red list of ecosystems around the world. You can see the Americas covered completely as a regional assessment. In Europe, similar, but there are many countries that are doing the same in various parts of the world, and assessments ongoing. So what we hope to do by the year 2020 is to have some summary of information that we could present to report on progress on the Convention on Biological Diversity and IT Target 5, and hopefully our initial objective that we set a few years ago was to cover the world by 2025. We'll see if we can achieve that, but I think that we can certainly say that we have advanced a lot in that direction. So that's a very rapid and broad overview of the history of the project, and I'm sure it's a history that will continue to shine into the future. Thank you.
Thank you, John Paul. Now I will give you an overview of the red list of ecosystem methodology. And first, to better understand the way of working, I will give you an idea of... sorry, I have a tendency to move around. And this is the structure of IUCN, how IUCN work and how is IUCN composed. So IUCN is composed by 3 main pillars. No, the pointing is not working. The first pillar is the staff. No, but not in the screen. We are composed by the staff. Secondly, by members. IUCN is a union composed by members. And third, the commission. The commission is composed by voluntary colleagues that can be science, could be policymakers, could be members of NGOs, etc., etc. And now I'm talking about the governance of the Red List of Ecosystem. The Red List of Ecosystem team is composed by the Secretariat, who is spread a little bit around the world. We have a program officer based in Cambridge. We have a team, the core of the team, who is based in Caracas. Staff also in Glon. Myself, I'm based in Glon, which is in Switzerland. And then we have other part of the team in Melbourne and Sydney. David Keith is one of the members who is based in Australia. Secondly, we have the steering committee. The steering committee is composed by different members. We have the lead and the co-lead of the Commission of Ecosystem Management. Also the chair of the Species Survivors Commission, who is John Paulo, who is here with us. The chair of the Commission of Ecosystem Management, the director of the Global Ecosystem Management Program, and then we have the head of the Science and Knowledge Unit, who is Tom Brook, who is also here with us. And it could be also other members from IUCN. John Paul Rodriguez, he's the chair of the Species Survival Commission, and Tom Brooks, who is just sitting behind you, he is the head of the Science and Knowledge Unit of IUCN. And the third pillar of the Red List of Ecosystem is the Committee for a Scientific Standard, who is composed by a chair, a deputy chair members, and also representatives from the Red List of Threatened Species. You may be wondering why to create a Red List of Ecosystem. Why? We have already the Red List of Species, and John Paul was talking about why an ecosystem. So we developed all the scientific behind developed this IUCN Red List of Ecosystem to support the conservation in resource and use management decision, but to identify the ecosystem who are most at risk, and also to assess the status of conservation of those ecosystems. And what the IUCN, I will say really too short because it is really a long name, and I will try to shorten it because if I have to repeat Red List of Ecosystem for 2 hours, it could be too much. So the IUCN really provide different, I will say different, or add some values. First of all, it is a standard method that we can replicate and we can scale up. We can replicate in different countries, and we can also compare different ecosystems over the world. Secondly, is a easily understood and easy to mainstream into policy making tools and policies. And third is a transparent, objective, and scientifically rigorous methodology. As I say, behind the RLE, there is a committee for a scientific standard in there, supporting the development of the RLE. And four is an applicable to all types of ecosystem. We can assess forests, we can assess coral reef, we can assess mangrove, all kind of ecosystem. Also, the IUCN RLE may be applied systematically to a set of ecosystem types within a specified area of assessment. So we can go through the local level to the global level, going through the national, subnational level. And also that means that the RLE is a flexible tool that can use different kind of data. And lastly, this is a consistent methodology and complementary with the IUCN Red List of Threatened Species. For example, last February, along with John Paul, we conducted a training in Abu Dhabi, and it was a joint training. The first part was a training on the Red List of Species, and the second part to the Red List of Ecosystem, to give an idea of how important it is to do both assessment together. And now I will go through the methodology. First of all, it's very important, as we are using the IUCN RLE, it's very important to define the ecosystem. Which ecosystem we want to assess, which ecosystem we want to analyze. That's why it's very important to identify the units. And when identifying this unit, then we have to take into account 4 different factors. The first one is the biota, which are the biotic characteristics of the ecosystem. Secondly, which are the abiotic characteristics, the key element, for example, which is the hydrology, which is the level of sedimentation, etc. Third, it's very important to think about the key ecological processes and interaction. For example, which are the relation between different species population, and first, the spatial distribution of the ecosystem. And as I say, the aim of the IUCN RLE is to evaluate the risk of collapse of ecosystem, but also to assess the level, the status of conservation of the ecosystem. You may be wondering, but what you say? What does mean collapse? Collapse is when the identity of an ecosystem is completely lost. The ecosystem is transformed completely his identity and lost his defining feature and is replaced by another ecosystem. So, for example, we have the case of the Aral Sea. The Aral Sea was one of the biggest watershed in the world, and now it's become a salty grassland. So you can see it's collapsed because he changed completely his identity. Which is the structure, or which are the criteria that are embedded in the red list of ecosystem? We have, yes, sure, of course. Uh-huh.
Don't you think if you leave it for some time, like, you just stay away from it for quite some time, wouldn't you think it will come back to, it will regenerate, or it will come back to what it used to be?
You understand?
Yeah, that's an excellent question. That's a really key difference between collapse and extinction. So the reason why we don't use extinction for ecosystems is precisely because, at least theoretically, any ecosystem, if all of its individual parts remain somewhere on Earth, you could at least theoretically reassemble it and it can be reached. So collapse is potentially reversible, while extinction potentially reversible, while extinction never is reversible. So that's a really fundamental difference between extinction and collapse, and that's exactly why we don't use extinct with reference to ecosystems, and we developed this definition of collapsed.
Because my understanding was it's gone, finished, not reversible. So yeah, that's the case then. Yeah.
No, you're totally right. That's very important.
It is a good. Then we will.
Normally, the endangered species, whatever it is, sometimes we need to manage it. We need to manage it in a way that we need to manage it in a way that we leave it for some times, and things will come back. It will be reversible. So that's what I've noticed in the ecosystem, especially like the plants, the animals, the habitats, different habitats.
David, is there anything you would like to add?
I'm sorry, I wasn't hearing all the audio there, so I can't really comment.
Okay, well, no worries.
And then we will talk about the different categories of RLE. So, and then I will come back to the collapse category, and we can discuss further. No, it was a really good question, because you are not the first person asking that.
And sorry, if anyone has any questions during the presentation, we meant to say this. You're welcome to interrupt us and when we're in the slide, and just let me know and I'll run the microphone to you.
Okay. So let's go through the methodology. The RLE method tool is composed by 5 different criteria. 2 of them, the A and B, are related to spatial symptoms of the ecosystem. The first criterion, A, is related to the decline distribution of the ecosystem, while B is related to the small distribution of the ecosystem. Then we have criteria C and D. C is the environmental degradation of the ecosystem, and D is related to the alterated biotic processes. Lastly, we have criterion E, related to the quantitative risk analysis of collapse. As I mentioned previously, we can use the RLE methodology at different levels. First, we can use the methodology more at the local level for a specific ecosystem. For example, if you see in the map, we have Madagascar, who is really focused on Madagascar. Or, for example, we can see in Venezuela, we have a specific assessment about the forest in Venezuela. Or then we can go upper level and go through the national or regional assessment, or even at a higher level, and we can go through the global assessment. Right now, we are working in 3 different types of ecosystem at the global level. We are trying to assess the Arctic boreal forest, the mangrove at the global level. That's why we are working with the Global Mangrove Alliance. And third, also we are on the way of assessing the coral reef at the global level. The IUCN RLEs are really powerful tool for informing. By the end of the year, we will launch the RLE database. It won't be like the last version of the RLE database, but it will be a compilation of all the assessment that had been done so far. You could find all the information on all the data generated in those assessments, and you could I forgot. And you could go through the RLE website and you can check all this information. Secondly, the IUCN RLE and the team behind the RLE has developed 3 different indices. The first is the Ecosystem Area Index, the second, the Ecosystem Health Index, and thirdly, the Red List Index for Ecosystem. If you want more information about, you can contact our colleague Jessica Roland. Her email is, and you can, of course, you can take a picture. Her email is on the bottom of the slide, and she could provide you more information. The Ecosystem Area Index measures the trends in the magnitude of change in ecosystem area over time. So it's more related with the spatial distribution of the ecosystem, while the Ecosystem Health Index measures the magnitude of change in ecosystem functionality, which is more related with criterion C that I mentioned previously. And thirdly, the RLE Index is a way of measuring the risk of ecosystem collapse and give a percentage of the ecosystem collapse. The IUCN RLE tool is helpful not only for providing an idea which is the conservation status of the ecosystem, but also can inform other sectors. For example, RLE can inform the international convention, for example, can inform the Aichi, the SDG target, but also can help prioritize the investment, because the RLE helps to identify which are the areas that need more urgent action. So then we are targeting the action, but also RLE is very helpful when elaborating and formulating restoration and conservation policies. So it's a very helpful tool for decision makers and policymakers. And also RLE can help informing ecosystem services. Let's go through different case studies, and maybe you can better understand what is the how and which are the results of RLE. As John Paul mentioned, 2 years ago, we finished the Americas assessment, who assessed the forest ecosystem from North America until the Patagonia, and the result is that 97 forest ecosystem are threatened, which is almost the 81% of the original forest area. Another example is the assessment of mangrove in Mayotte. Our colleague from the IUCN French committee has assessed the whole mangrove ecosystem in the country and identify which were the main threats affecting this ecosystem. As you will see in the slide, for the stemland mangrove, The most important threat was the disruption of sedimentary dynamics and the loss of characteristic native biota, which is more related with criteria C and D. The second type of mangrove is the central and internal mangrove, were threatened mainly by the wastewater discharge in the future. And the third type of mangrove is actually critically endangered. Another case is Colombia. Colombia has conducted two early assessment at the national level, and they have embedded the result into national policies on restoration and conservation. And which is the result of embedding the result of the RLE. RLE allow to evaluate the degree of representativeness of the threatened ecosystem within protected areas and help to the creation and management of new protected area and help and underpin the tool that you can see here in the screen, which is a tool called Tremartos, who is helping NGOs and governments in developing specific development project on threatened ecosystem. This is what I mentioned. The result generated by implementing the IUCN RLE in Colombia has been used to develop national restoration and conservation policies. And then Australia. Australia is the country that has mainstreamed the most the IUCN RLE methodology so far. They have used RLE into environmental regulation and development approval on land zoning. Also have been used in the development of offset policies, but in recovery planning, protected area management, and water management, which that means that the IUCN RLE has been really mainstream at the national level. Thanks to the team and thanks to David, that is one of them who is on that. Finally, I will give you some link and list of which are the tools and resources that are available in our website, and you can access. They are all open source and free. First, we have the RLE website. Second, we have the Remap. Remap is a tool that can help you creating maps. If you don't have the spatial map data necessary for criteria A, then you can use it to develop simple maps, but only related to the present. To the present, not to create past or future maps. Third, we have the guidelines. We have training book. We have a library of case studies. We have all more than 40 case studies that are available in our website. We have also available, we have just finished a training workshop curriculum that is also online in Spanish, French, and English, along with others document. Then we have our air package, mostly for doing a statistic, and also an RGA install booth and a user e-forum. If you have any question related to an assessment, if you are really struggling with a specific question, then you can send a message to the user e-forum and then he will respond to you. It's not confidential. You can. Sure.
So the question was whether the PowerPoint will be made available?
No.
Yes.
Yeah. Here we have. There is another question.
Yeah, thanks. So yeah, I guess I could have waited, but actually I have a burning question about your methodology. So when you look at the vulnerability or resilience of an ecosystem, how do you take into account functional diversity or redundancy? So a extreme example of that is ICER was brought up in the Arctic context, and Arctic ecosystems, at least terrestrial and freshwater ones, tend to not have much redundancy. So you lose one species, you get this cascading effect. And so they're arguably, or at least in theory, they're very vulnerable to a disruption or a change, and you will lead to collapse and perhaps even extinction. So I'm just curious, I was trying to sort of envision it within that diagram you had where you had this sort of threats and the degradation coming in. I'm just wondering if you could just help me understand how you look at things like diversity, functional diversity or redundancy in that model.
The second part of the presentation is about conceptual models and how to use the different criteria. So if you prefer, also, we can go to the slide and then it will be easier to respond to your question. Thanks. Someone else? Any question so far? Yeah.
The slide you had on the map, where you showed the different areas being covered, I was just wondering, is that representative of your area of focus going forward? Because so the next one.
This one?
Yeah, when you have all the, yeah. I know you had a lot of maps. Where you showed mangroves, coral reefs, forests, yeah. So obviously I'm kind of seeing the gap there, which is in this region. Is there a reason why am I right to read into the fact that you're not going to be looking at this region? Or
No. I think it's just because it was moved. The rectangle was a little bit moved. No worries about it. We will also take into account the coral reef who is in the Caribbean region. So, and one of the assessment that had been done is in the Central American, integrating Mexico. So it's just a matter of representing matter. We will take into account this area. Yeah. We are not making exceptions. Yeah.
I see a little activities in the Middle East. I don't see much of activities. Or in the Arabian Gulf region, I don't see much of activities as much as it is in North America, South America, Europe, for instance.
That's true. So maybe it is a way to start doing more activities in the region.
Yeah, the European Commission ran a project evaluating the ecosystem risk in Europe. We did the Americas mainly because we were using a ecosystem classification developed by NatureServe that was focused on that region of the world. We did start the red list of ecosystems and species of Abu Dhabi this year with the idea to expand it, to use it as a model to expand. So it's a combination of opportunities and local interest as well. So we respond to some extent to what other countries and regions want to do and try to work together. So I'm sure that there will be nobody would like Veronica said, we don't make any exceptions. Anybody who's interested, we definitely move forward. Absolutely.
If you can see here in this slide is targeted assessment. So it depends also. For example, there is a government that reach us and ask, please, we want to do a national assessment specific, for example, of mangrove. Right now, we are conducting a project in Mozambique, and we are assessing mangrove, coral reefs, seagrasses, and coastal forests. And it's the government who came.
Fortunately, I met Mr. Stewart, and he was telling me that there are some activities there. But sometimes, maybe this is something, some of the issues I've discussed with the directors, Dr. John in Amman, the regional director of IUCN in Amman, and Dr. Stewart. And, sometimes we need to initiate because maybe here we have lack of knowledge and lack of information what IUCN can do and what they can provide. I myself, a member of Commission on Ecosystem Management, CEM member, but we're facing some difficulties toward these issues actually. So the awareness and the presence of IUCN, and this is one of the challenges that we spoke about, to have a representative office or something within the Arabian Gulf, because we have a lot of issues here. And it's like, it's actually time to really work on the ecosystem and the endangered species and things. We talk about it, but we never actually work in the ground. Yeah.
Because you have the resources. In February, when we were in Abu Dhabi, the colleagues came with maps with a incredible resolution, 5 centimeters. So you have the resources. We just need to put it in place. and to work with these
Not only Abu
resources.
Dhabi, but we're talking about,
The whole
because
is
we have the Arabian Gulf,
Mhm.
let's say, in total,
it's like an
for
example.
instance,
Yes, as an example. Yeah. Which is your name, please? Okay, thank you. Thanks. And then we go through the second. Now we are going to the session 3, and it will be David Keith who will be presenting the global ecosystem typology. David, would you like to share your screen, please? And then we can see here.
I'm sorry, you'll need to help me out. Where do I find share screen?
Yeah.
It should be at the bottom right.
Bottom right of
Bottom
Skype,
right.
it should be a little icon that you click on and it says share screen.
He's not on Skype.
Sorry, David, you're about to be made presenter. If you just give us a couple of seconds.
Okay.
Brilliant. And David, are you happy for people to take questions during your presentation, or should they wait until the end?
Yes, I'm happy to take questions.
Great. And if you can just accept the presenter role.
Yeah.
Yeah.
Okay.
Mhm.
Great. Sorry. Okay. Well, thank you very much for inviting me, and thank you to everyone who's joined us on the web. I'm going to speak now about a project that we're doing, which is part of building the infrastructure to support Red List of ecosystem activities and assessments. So I'm first going to talk about why we're doing this, building this typology of ecosystems for the world, and then I'm going to talk about the existing typologies of ecosystems that we reviewed in preparation for developing this one. I'm going to talk a little bit about the theoretical foundations of it, and then I'm going to move on and talk about the actual detail of the hierarchical structure as it currently exists, and talk about the progress that we've made in developing the typology, and take you through a little tour of some of the ecosystem groupings that we're working on. And finally, I'll just run through some of the products that we're aiming to produce from this work. So what we're looking for with this ecosystem typology is actually a framework that would help us make generalizations about ecosystem change. And so we wanted to try and develop a system that would help us group ecosystems together that share similar functional traits and similar threats and similar drivers and similar indicators that we could use to monitor change in those systems. And that's really one of the key underlying goals to the whole effort. We then downstream, once we have this understanding of ecosystem change, we want to be able to use that information in conservation planning. So we want this framework, this typology, to help guide the delineation of different units that we will assess risks to, and also units that will help us make decisions about spatial planning. Where is the best place in a landscape or a seascape to put some new infrastructure, a new development? Where are the best places for protected areas? Having a systematic and consistent definition of these assessment units right across the world is actually quite important for higher level reporting as well, for instruments such as the Aichi targets and sustainable development goals. Thirdly, we wanted to try and build a system that will help facilitate translation across existing typologies. The world is full of different classifications of land units and sea units that there's been considerable investment in by different groups of stakeholders. Different national governments have their own classifications, and we want this global system to be a means of translating and comparison between those different systems that have been developed independently or semi-independently in different parts of the world. And fourthly, we want a system that will help us make the most of scarce data. We, for example, want to be able to draw inferences about similar kinds of ecosystems. We may know something about a forest in one part of the world that could actually be useful for ecosystem management for a similar kind of forest somewhere else. And also by integrating, the local expertise, because that's where most of the detailed knowledge about ecosystem dynamics and ecosystem management actually resides. It resides with local people who have the expertise and the familiarity of those ecosystems. So we very much wanted to build in a bottom-up component rather than have an entirely top-down kind of system. And I'll come back to that point a little bit later. So yes, the key principle that we're aiming to achieve with this is enabling these generalizations about ecosystem change. But it wasn't long before we were into this this project that we realized that there's actually a lot of other uses that such a system might help apply. And these are some of the processes that we think a global ecosystem typology might also be useful for, in addition to the red list of ecosystems. Defining diversity areas, helping to make decisions about ecosystem monitoring and management, comparing different kinds of ecosystems around the world for research purposes. We don't actually have, a standard definition, for example, of things like savanna. So we need, definitions that that people in different parts of the world can use and say, well, this is the label that applies to my particular system. Education is another important application. If you're a school child, there isn't actually one point of truth that you can go to on the internet to find a list and a description of all the different types of ecosystems in the world. Natural capital counting is another application that I'll say a little bit about towards the end of the talk. And finally, global reporting instruments such as the CBD and Aichi targets and the Sustainable Development Goals. These kinds of systems need a common infrastructure and a common language to enable us to report at that kind of level. So in order to achieve a system that does these kinds of things, we came up with a number of design criteria. And perhaps one of the most important of those is the one at the top here. It needs to represent ecological processes, because unless a system of classification can represent those processes and represent them well, it's not going to be able to inform us about how to manage ecosystems to sustain their biodiversity and sustain their essential services that they provide to people. The second important quality that we need in a classification is that it must represent variation in biodiversity itself, because we want to use this system of classifying ecosystems to inform us about biodiversity conservation. So it has to tell us something about what systems support different groups of biota. Thirdly, it needs to be scalable, which means that it needs to be applicable both at local scales, at regional scales, and also at global scales. So we need some kind of framework that we can apply at those different levels of detail. Fourthly, it needs to have consistent coverage across the entire biosphere. Many existing classifications have a partial coverage. Some of them deal only with land, for example. Others are confined to marine ecosystems. Fifthly, a typology needs to be spatially explicit. In other words, we need to be able to map the units of ecosystems so that we know where they occur and that we can assess risks and also prescribe different management strategies. And then lastly, a system needs to be simple. It needs to have a manageable number of recognisable units that people are comfortable and familiar with. And it needs to be able to be referable to many of these other established classifications that may be more purpose-built for particular purposes or in particular kinds of ecosystems, such as marine ecosystems. So you may well ask, why do we need yet another one of these? Because there's actually quite a lot of existing classifications in existence, and some very good work has gone into their development. But when we got down and examined a number of them available, we reviewed 20 existing global ecological typologies. We found that none of them actually met all of those 6 design criteria. Most, in fact, were specific to one realm. They were entirely terrestrial, or entirely marine, or entirely freshwater, such as the Ramsar system. And in fact, only 2 covered the entire biosphere, and these generally lacked a consistent rationale for synthesis and classification across, those diverse components of the biosphere. And furthermore, neither of them were actually mapped. So, so one of the other things that was largely lacking amongst these 20 systems that we reviewed is that many of them lacked a clear theoretical framework. So that we thought was perhaps a place to start, and we started to think about, what would be a common fundamental theory that could help us work through and develop this typological system. And we landed on ecological assembly theory, which basically says that the makeup of any particular community or ecosystem at any particular place in the world is a function of a number of drivers, or if you like, evolutionary filters that are processes that influence the makeup and character of any particular ecosystem at that place. And that character of the system can be defined by a number of ecological traits that you see there in the green circle. So we can talk about some ecosystems that are very highly productive, others that are not so productive, some that are highly diverse, both in terms of taxonomy, but also in terms of function. We can talk about traits that relate to the trophic structure, how diverse different levels of the trophic structure are and which levels might be dominant, whether it's predominantly a top-down kind of organisational system or a bottom-up one that's driven largely by primary producers. Many of the organisms that inhabit ecosystems have very characteristic traits of life forms and life history and phenology and also ecophysiology. So all of these traits are things that define the character of different kinds of ecosystems. And those are shaped by a number of different processes. Some of them are essentially abiotic processes, they're environmental or physical processes, and those include the fundamental resources that you see in the top box there: water, nutrients, oxygen, carbon, light and other sources of energy that are essential for everything that lives on the planet. Those are the fundamental resources that and the availability.
Sorry, David, you're breaking up a little bit there.
I'm sorry?
David, can you hear us? You're breaking up a little bit.
Yes. I'm sorry.
Oh, you seem to get back.
I can hear you. Can you hear me now?
Yeah, you're back now.
Yeah, I'm sorry. My connection is not ideal, but
Just
I'll try to go on. Okay. So as well as resources, there are a number of other environmental drivers. For example, we have these ambient processes like temperature and salinity that are not resources that plants and animals use, but they regulate how available those resources might be, or at least the ability of different plants and animals to capture those resources. And another aspect of the environment is these disturbance regimes over here in the red box. So things like recurring fires and floods and storms that are a natural part of the environment and which can be very important in shaping different types of ecosystems in particular environments, such as tropical storms, for example. And then down here in the bottom, we have the biological component of the drivers. So the way that organisms within an ecosystem interact with each other, the competitors, predators, pathogens, mutualists, and the ecosystem engineers that influence the way that ecosystems are shaped. And then finally, there are people who, with technology, have changed land cover and use resources, extract minerals, timber, harvest fish. We move biota around from place to place. And of course, on a global scale, we're having an impact on the global climate. So all of these things influence and shape the character of different ecosystems. And those factors, those drivers, if you like, all interact with each other in part of that shaping process. So this model is actually quite useful in shaping and defining different units of ecosystems within a typology, because it focuses our attention on defining different traits that distinguish different ecosystem types from one another, and also the drivers that influence the different processes that operate and sustain those ecosystems. Now, a second aspect of theory concerns classification theory, but before we move on to that, I wanted to show you the kind of structure that we're developing to represent those processes, which is a hierarchical one, which is important because a hierarchy enables us to scale from very broad global levels down to very local levels. And the hierarchical system that we are developing at the moment has 6 levels of classification. The top one and the broadest one is what we call realms. And I've illustrated 3 of the 4 realms here, the terrestrial realm, freshwaters and saline wetlands, and the marine realm. And in addition, we have a 4th one that we've split from the terrestrial realm, and that's the subterranean realm. And within each of those 4 realms, we define a number of biomes, which are familiar kinds of units to most people who may have studied biogeography. So things like tropical rainforests and savannas, different types of wetlands, different types of marine ecosystems such as corals or kelp forests. And then at the 3rd level, we have these functional groups, which are essentially units within these biomes that are distinguished from one another because they have different organisational processes and different drivers. So they have some major functional differences. So you might imagine, for example, that we have a number of different tropical rainforests within those functional groups. Some of them might be montane cloud forests that function rather differently to the lowland forests. And of course, tropical dry forests are very different to both of those other forests because of the seasonal drought and the traits and adaptations that those forests have to cope with those kinds of environments. And I'm not going to say much about the more detailed level, but essentially these are levels that represent different species composition, if you like. So the top levels are largely about functional attributes, irrespective of the species that are engaged in those functions, whereas at these lower levels we start to distinguish different types of ecosystems that are fundamentally different, even though they're functionally similar. Those functions are delivered by distinctive groups of species. And our approach in developing this framework is that largely we go top down for the functional component, in other words, the top 3 levels, because that's where we need to have the global consistency. But the lower levels is very much a bottom-up task, because that's where the expertise resides. And we think that it's important to build in local ownership, because there's a much better chance of a system like this being used if local people have ownership of what they're working with, rather than have something that's imposed from some central, global group. So yeah, the rest of this talk I'm going to focus on these functional levels of the classification and give you a quick look at those, but be mindful that there's a lot more detail within them that will be, and indeed has been, in existing classifications already worked through in many countries around the world. So the kinds of constraints or characteristics that we want this classification to provide include that the units need to be mutually exclusive. In other words, unique membership all through that hierarchy. We want to be able to represent scale in some kind of hierarchical or nested framework that I've just shown you in the previous slide. We also need to recognise that fundamentally nature is continuous. Okay, it's not really a set of boxes with discrete boundaries and lines between different types of ecosystems. Different types of ecosystems tend to grade into one another because nature is continuous. So we want to be able to continually recognise that the nature of that variation, and recognise that to some degree this kind of system is going to be artificial but useful as a descriptive tool. And finally, these 2 points about the top-down and bottom-up approaches to construction. On the one hand, we want to promote consistency and robust generalisation, so we need some top-down input into those upper levels, but at the same time we want that local ownership and the realism that brings from the knowledge that comes at that level. And so the top 2 levels, I mentioned there are 4 realms, and you can see them outlined here, and I've deliberately arranged this diagram in a way that illustrates that continuous nature of ecosystems in the world, rather than discrete boxes that are arranged in a neat hierarchy as in the previous diagram. So it's convenient to, for example, think about savannas over here in the terrestrial realm as somewhat transitional between tropical forests and deserts, with some ecosystem types that might be somewhat intermediate in their characteristics between them. And you can see that each of the realms overlaps with others, and we have these transitional realms such as seashores and transitional waters such as estuaries and inlets that are actually quite important to recognise. So that kind of thinking is important in recognising the continuous nature of ecosystem variation across the globe. The third level of the hierarchy is one that I think is actually very important from a working point of view, because it's the one that we really need to help us make these generalisations about ecosystem change. These functional groups of ecosystems at level 3 are defined by shared ecological traits and key processes that shape those traits. There are going to be about 100 of these ecosystem functional groups across the marine, terrestrial and freshwater and subterranean realms. And the definitions of those units are based on a survey or a review of the literature, input from a large network of experts, and also a review phase that will be starting shortly. And we're also in the process of developing descriptive profiles so that people can get a quick understanding about the nature of each functional group. So now I'm just going to take you through very quickly to illustrate the kinds of functional groups that we're beginning to recognise. So this is the marine realm, and you can see that we have 4 biomes currently recognised in the marine realm, and on the subtidal continental and island shelves and shelf breaks, we have a range of different functional groups that include seagrass meadows, kelp forests, the photic coral reefs, and you can see a number of others that I won't go through individually there. Out in the open oceans, we have 4 different functional groups that are largely defined by their depth. And in the deep ocean benthos, we have a number of different formations there, defining different types of sea floor that are recognised through uniform plains, through to canyons and hydrothermal vents, and so on and so on. And finally, a group of to accommodate artificial ecosystems under the oceans. So as I mentioned, for each of these functional groups, we're developing these profiles, and you can see that a profile will include just a single page. It's pitched at non-specialist users, and it includes simplified explanations of the ecological traits and the key drivers that characterise different ecosystem groups, as well as maps of their distribution and some key references for further information. And they're also illustrated with a photograph and a diagrammatic model of the key components and the key processes that shape those systems, as well as those global maps. So in this example shown here, this is seagrass meadows. I'll take you through. We have a diagrammatic model there that illustrates some of the features of this group of systems. They have very high productivity, which is shaped by these foundational seagrasses that photosynthesize and capture light energy from the sun. They have structural complexity, which is very important for coexisting epifauna and epiphytes, and also important breeding sites for a number of fish. And they have considerable trophic complexity in terms of the network of interacting consumers as well as primary producers and predators. The key drivers of the systems.
This is just your
Yes.
2-minute warning for the end of the slide.
Well,
Yeah. Okay.
So these are defined by clear waters, low to moderate turbulence, and the sandy substrates in which they grow. And they have a tropical and temperate distribution around the continental and island coastlines. So that's one example of a series of different functional groups that I'll just skip through now. In the transitional realm between freshwaters and marine biomes, we have a number of different functional groups that include intertidal marshes, mangroves, fjords and other deep coastal inlets. In the freshwater realm, there are 3 biomes that include rivers and streams, different types of rivers and streams, upland, lowland, those that are frozen on the surface, those that are seasonal or perhaps episodic in their flows. Similarly with lakes, large, small, permanent, frozen, episodic, and periodically dry salt lakes. And then of course there are the artificial waters. An example there of a profile for one of those freshwater systems. In the transitional realm between freshwater and terrestrial, we have a number of different palustrine wetlands, some examples there of floodplain wetlands, as well as others like mires and bogs and peatlands, geothermal wetlands. And in the terrestrial realm, we have about 8 biomes with a number of different ecosystem functional types recognised there through forests, shrublands, woodlands, grassy systems, deserts, cold places, and anthropogenic artificial systems like croplands, urban environments, and plantations and sown pastures. Next we have, sorry, I'll skip that example. We have the transitional realm between terrestrial and marine, and these include the shoreline systems, of which there are a number of different groups. And finally, under the ground, we have a number of different subterranean systems, including dry caves and endolithic systems, microorganism systems that live inside the rocks, as well as aquifers and other underground aquatic systems. So our next step will be to undertake a review. We'll be seeking input from targeted experts as well as through the IUCN specialist groups. We'll be asking which kinds of functional groups are represented in particular regions, and we'll be interested to know what gaps exist in typology for systems that are not currently represented. And finally, I just want to say something about other applications. We're currently working with the UN System for Environmental Economic Accounts to see what kind of synergies there may be between this kind of system and the ecosystem types that they might want to use in terms of reporting on natural capital accounting. Thanks very much. I'll leave it there.
Brilliant. Thank you very much, David, for that presentation. So we're doing a slight change because we'd like to fit in these questions, so there'll be no break. And actually, there's a couple of questions for David that I'll read out from online users. For people in the room, don't worry, the last bus is at 6:50, so you'll have plenty of time after the session. Not the last bus, sorry. A bus is at 6:50 for you to catch your bus to the hotel. So a question for David, I believe, was the theory. If we go to the bottom, please. It was the last question. And then we'll move on to a few for Veronica, although I'll have to be brief. Can we zoom out? I believe one, David, was whether the theory has been published behind the typological framework?
Not yet. We're working on a draft at the present, and yeah, hopefully we'll be submitting that early in the new year for publication.
Brilliant. And yes, and the same question for the theoretical foundation behind RLE, if that's published and available. I believe that's open access, actually, if I'm correct.
It is.
Yes.
Yes, that's correct. Open access in PLOS One. You can also access it through the RLE website.
Brilliant. So then I have a few questions for Veronica, and like I said, we'll keep it brief because she's going to take us through the categories, criteria, and we'll also be looking then at the applications with a small interactive exercise at the end. So if we could go up. One more. So this is two questions, I believe, from the same person. Any study on industries which are causing damage to ecosystems? Any program to reach out to such industries and offer them information and technology details to prevent this damage? Mostly industrial waste is responsible for ecosystems coming into the red list. I hope I pronounced this right. Haliji and Kensha lakes in Pakistan are examples of this kind of damage to ecosystems, both are freshwater reservoirs. And then following on from that, the Mabel Agustowski had heard that we start assessing when governments approach us from a certain country. It also goes both ways. But in the case of the Mediterranean, oh, sorry, this goes to another question. So first of all, to do with the waste industries.
We don't have a defined or an established program to reach industries. And this is still an exploratory domain for us. We are still exploring how to reach the private sector and how they can reach us. For the moment, how we can use RLE is to identify their action or their activities as a main threat for the ecosystem where they are developing their activities. We can include as a main threat, and I will talk about later on the conceptual models and to respond also to the question that our colleague who is sitting here. And then for what you say?
There was another one. Are we planning to look into red list of ecosystems in the Mediterranean?
Mm-hmm.
And in the case of the Mediterranean, this is Mabel Agustowski. This would demand a regional effort, and she's asking whether there are any other funding partners. So we talked about governments approaching us. Are there any other funding partners, and is there a regional scope as well, specifically towards the Mediterranean?
There are different ways of funding RLE projects. So it could be governments who come to us and ask for doing an assessment, or it could be that funding. We can develop proposal and then we go for funding. And depending, of course, of the amount of the funds, we can go for a more local project, or we can go for a higher scale. We can scale up the project. And in the Mediterranean, I have to say that a few assessment has been done so far. We have the red list of ecosystem in Tunisia that is undergoing. Lebanon also, I think it was last year, also interested on doing a RLE assessment. And then we have the RLE in Europe. No, but it's not using the IUCN classification, it's using the European Habitat Classification, EUNIS. Yeah, exactly. But nothing at the regional level. It could be some, it will be necessary to join effort for doing an RLE assessment on the whole Mediterranean basin.
And that's something that people can get in touch with either Veronica or myself, Jean-Paul, anyone on that first, that slide of the governance of RLE, or just IUCN in general. Yeah. And just to finish off, I have two very similar great questions, one from Amita Deb and another from Anupama Chowdhury. Amita is asking, how can CEM volunteers, young professionals, involve themselves with RLE? And a similar question, can students take up academic projects with ecosystem assessment? And are there guidelines and data available for academic research?
So all the documents are available on the website related to the student and how they can help us. They can see in the website there is few PhD that have been done using the IUCN RLE methodology for assess. For example, in Brazil, one PhD has assessed all the ecosystem Mata Atlântica ecosystem. Of course, and it is very important to have a student also working with us because they can help us get, fill in the gaps in between science and implementation. Yeah, yes, of course.
In fact, on one of the slides, Jessica Rowland, with the indicators, that's also her PhD work. Postdoctorate, professor, that's something we're very open to. Absolutely.
Yeah, it's very open. And yeah, it was a third.
No, that was it together. It was about CEM volunteers and students, and of course we love CEM volunteers to get in touch with us.
If they want to volunteer, it's just necessary to go through the commission website, Commission of Ecosystem Management, and within the commission there is different group, and one of them is the red list of ecosystem thematic group, which Debbie is leading this thematic group.
Great, so I believe that's all the questions for now. Veronica is going to take us through the categories and criteria, and then we'll look into applications with everyone. And I just want to say we have a pretty high number of people online, I think 63 and counting. And maybe you can't see this, people, because everyone seems to have sat just outside the camera scope, but we do also have people in the room. They're just hiding from the camera here. Okay.
So let's go through. Maybe, yeah, this way. Yeah. He seems quite empty. Oh, maybe you can sit all together and then it's like look like more crowded. Yeah. Okay.
Good to see you again, David.
Oh yeah, sorry. That was good to see you again, David.
Okay, let's go through session 4, so then we can pick up the bus at 6:50. First of all, if necessary to talk to introduce the camera. So yeah, and then everything is disconnected, so I don't have the no. Okay. Let me first introduce a couple of key concepts to understand better the IUCN RLE methodology. The first is the conceptual models. What is a conceptual model? A conceptual model is a diagram that registers the reality of the ecosystem, including different aspects, including the threats, including the biotic characteristic, abiotic environment characteristic, and also the relation in between the different components of an ecosystem. These conceptual models are very helpful for the assessor because these models help to clarify the assumptions, and also they are very helpful to understand the consistent processes. Secondly, it's a very useful communication tool that can be understood by policymakers, decision makers, scientists, etc. And also, these conceptual models provide a basis for conducting the risk assessment, and they can help identifying which are the main variables that we need to assess. And this is an example that you can see better up. In green, you can see all the characteristic biota of the ecosystem. In blue, the abiotic environment characteristic. In red, the threats. And you can see which are the relation in between all these components. And then when assessing the ecosystem, it will be much easier for the assessor and for the people who will be reading the document to understand which are the main processes and why these threats are affecting the ecosystem. The assessment can be done using different time frames. There are 4 defined time frames. The first is the future. The future is the 50 years from the present onwards. Then we have the any 50-year period. We can use the past 10 years and the 40 next year, or we can use the 20 past year and the 30 past year. But we always have to use a 50 years period. Then we have the past time frame, which are the 50 last year period. And we have lastly the historical time frame, which is the most difficult one to be assessed because not quite often we don't have enough data or the data is not available. And this time frame is from the present until the 1750. And the third key term to mainstream when using this methodology is the threshold. The threshold are used to delimit the ordinal category of risk. The threshold is not used to provide estimation of probability of collapse, but better to delimit the different categories of RLE. And I will go further explaining which are the main categories of the RLE methodology. As mentioned previously, we have the RLE is composed by 5 different criteria, 2 spatial criteria, 2 functional criteria, and the last one is for modeling, for evaluating the probability of collapse. And by using the 5 different criteria that I mentioned and taking into account the different threshold for each criteria, we have different categories of risk of collapse. We have 2 of not threat, which are the less concerned, the green one, the 2 greens, and near threatened. We have 3 categories of threats, critical endanger, and vulnerable. One reflecting the lack of information, the gray one, data deficient. One for collapse, the black one, collapse, and one for ecosystem type which have not been yet assessed. It doesn't mean that we don't have the data. It means that we have this ecosystem hasn't been already assessed. Let's go through each criterion. The first one is the criterion A, which aims to identify the ecosystems that are undergoing decline in the area. For assessing this ecosystem, we need different type of what we need is a spatial data that can come from different sources. It can be used. We can use remote sensing. We can use satellite images, field data, paper maps. We have maps. If we want to assess the time frame historical, then we need paper maps, maps that come from years and years ago that can be digitalized then. And also we can use the expert of knowledge. For example, in this project that I was talking before in Mozambique, we are using also the knowledge that comes from the communities, the local communities, because they are the one who lives in the territory and they are the one who knows better their region. The second criteria is the criterion B, related to the district restricted distribution. This criterion is mostly used for ecosystems that are really in a very restricted area, that they are not very common. And within this, within this criterion, there is three main terms to be understand. The first is the extent of the extent of occurrence, which is the minimum convex polygon enclosing all existing occurrence. As you can see in this example in the screen, this polygon is including all the pixels where the ecosystem is represented. And the second term is the area of occupancy. But the area of occupancy, if you want to assess this sub-criteria, we have to use a grid which is 10 by 10 kilometers, and then using this grid, we can identify which are the pixels that are representing the ecosystem at least at 1%. Because if you see the difference, the maximum convex polygon, it could be, for example, 5,000 kilometers square, while the area of occupancy could be only at 10% of the 5,000 kilometers square. And the third key term is the location. The location is a term which is related with a threat. If there is no threat, there is no location. Location doesn't mean that this ecosystem is located in a certain space within a determined area. It does mean that the ecosystem is threatened in a specific location. For example, if you see in this, it's going so fast. If you see in the screen, okay. If we take into account only one of the threats, I mean this one, that means that we are only one location. That is one portion of the ecosystem that is being affected by this specific threat. Criterion C. Criterion C is related to the functional processes of the ecosystem and is used to identify the ecosystems that are undergoing environmental degradation. When assessing this criterion C, we need to identify which could be the main variable that are affecting the ecosystem. And we have different examples. For example, desalinization, erosion, difference in the hydrology, for example, for a mangrove ecosystem, sea level rise. We need to identify which are these main variables. And when doing the conceptual models, then that help us to identify which could be the main variables that we can use, as maybe responding to your question. Then criterion D. Criterion D, similar to criterion D, but in that case, we have to identify which are the biotic variable in this case. For example, abundance of key species on the functional diversity of the ecosystem. And when doing the conceptual models, then you understand easily which are the variables. And also, it depends also on the data available. Maybe you think that one variable is more important, but you don't have the data. So then you have to pass to the second main variable that is affecting your ecosystem. It's also a matter of data availability and quality as well, data quality and data availability. And lastly, we have criterion E, which is related with the probability of collapse of an ecosystem. And criterion E allows for an integrated evaluation of multiple threats that we also identify when doing these conceptual models. That is something that we have to do as the baseline when conducting an early assessment. And this criterion E helps planning appropriate conservation action, is applicable at local, national, regional, and also global level. And when using criterion E, it will be necessary to go through all these steps that you can see here. First, it's necessary to define a model, which model we want to use, and it depends which the purpose of the assessment of criterion E. Then we need to pass to a specific model concept and to conceptualize the system. And at the end, what we have is an interpretation and documentation of the criterion E according to the different scenario. For example, if we want to know what will happen with mangrove in, I will say mangrove in Mozambique, talking about Mozambique because I'm really involved now in Mozambique. We can define different climate change scenarios. And according to those scenarios, we could have different results that can be then translated into recommendation, for example. And after introducing you all the criteria, category, etc., I would like to go through this session 5, which is stepping through an assessment. So far now, a high number of assessment has been done at different scale in a different region in the world, in America, Europe, Africa, Oceania, etc. And the results are very different according to the assessment. But it is necessary to keep in mind that when implementing and conducting an early assessment, there are 3 questions that have to be responded. What we want to respond? What is the aim of the assessment? What do we want to assess? Where we want to conduct our assessment? We want to do it at the local level? We want to do it at national level, at the country level, or we want to do it at a regional level, or we want to do it at a global level? And how we want to conduct this assessment? Who we want also to involve, and who is asking for the assessment? And these are the main steps that we follow when doing an assessment. The first is to identify a working group. So we need to identify the expert. If we want to go an assessment on mangrove, then we have to identify which are the main experts working on mangrove, for example, in the country. Second, we need to understand the methodology. We cannot go and run an early assessment without understanding what we are doing. We really need to read the guidelines, to read some assessment that have been done, and then to really understand the methodology, to then ask the what we want to assess and why we want to assess. Third, we need to define the assessment units. It could be a problem that you can maybe face when implementing early assessment is the boundaries. We want to stop at the natural boundaries of the ecosystem, or if we are doing, for example, a local level, we should be limited by the political or the geographical boundaries. That is something also very important that we have to take into account when defining the assessment units. 4, it is very important to do the data preparation. It's very important to compile the data as much as possible and do this research, and then compile all this data to then identify which are the variables also that we can assess. 5, conducting the assessment. After doing all this pre-assessment, then you can go and run an early assessment to then provide the result that you expected. This should be the result responding to your question, the what. And then once you have those results, it should pass through a validation process. This validation process need to be done also in combination with the expert that you identify in the step 1. Finally, once the results are being validated, you can publish your assessment. And the core of the assessment corresponds to the definition of the ecosystem unit typology, and then the criteria assessment, finally the ecosystem evaluation itself. And as I mentioned, before implementing or conducting your early assessment, you need to do a sort of pre-assessment. And first, you have to identify and define assessment units. 2, then once you have identified your assessment unit, you can describe them. You can provide a definition about the extent, which are the main characteristics, the main threat, etc. So we need to have a description to understand the assessment. 3rd, the data compilation. You need really to identify which are the main experts that you can contact, and they can help you then running the assessment. And it's very important to do the data compilation and to also evaluate the quality of the data that you have. To then identify which are the pressure component and threat. So that's mean to develop your conceptual model. And I can explain, the assessment can be done differently, depending on also who, for example, if it is a government who is reaching us, or it is us, we are reaching out the government, or if it's a funding project, etc. But the most important is to do first an inception workshop. And in this inception workshop is where you gather all the experts. All the experts are sitting in the same room and all are discussing about your pre-assessment. Because once you are doing your inception workshop, you arrive with all the data that you have been compiling before. And it is a discussion in between the different experts to then run the assessment. And there is a IUCN and CEN members that are providing support and guidance during the process. You are not alone. Assessors are not alone during the process. We are behind them and we are helping them. And I forgot, during the session workshop, it's not only discussing about the data compiled so far, but it's also, the session workshop is also used to train the assessors who will be doing the assessment. Sometimes it could be us, IUCN, who runs the assessment, but other times, most of the time is the assessor. We are training the assessor and they are able to run the assessment. And lastly is the validation, where we validate the data generated. And once we have finished our assessment, it could be published in a form of sheet. For example, in the left side, it is the IUCN French committee is their way of providing the results generated by implementing the RLE methodology. As you can see, you have the name of the ecosystem, and then in the blue box, you have the description of the ecosystem itself. And in the bottom, you have the different results by criteria and sub-criteria. And other option for publishing the assessment is a scientific paper as well. Oh. Okay, I wanted to put this. And oh, why? Okay. When running also the assessment, is very important to justify and document all the assumptions. We cannot just assume that a certain ecosystem is affected by a certain threat. We need to justify and very well document. And also we have to identify if there is any other missing factor in the conceptual model and in the assessment to avoid mistake and to generate the right results. And finally, which are the key messages that we have to keep in mind when running this assessment? First, when reading an assessment, what we need to think about it is, are they well defined and consistent, the ecosystem unit that we are assessing? Second, the assessment criteria. We need to adapt the assessment, and we are running the right assessment. Third, it is well documented, or we are missing any factor, as I mentioned in my previous slide. And then the fourth area of analysis. We are really focusing in the right area, or we need to redefine the area of assessment. And also we have to think about, when starting an assessment process, what is the question that we want to answer? I mentioned before, what? Why you want to run this assessment? Because then once you have the result, you have to respond to the question that you identify at the beginning, not a new question. That means that you are not responding the first question, so the process hasn't been done properly. And which area? Maybe we are assessing an ecosystem at the local level, but maybe it wasn't the right scale, and we needed to go to a higher scale. And if we are responding to all these questions, then let's start. We have to identify the team who we want to have involved in the assessment, which are the tools that we can use. we are conducting the training. We need to train the assessor, which is the time bound. How we need to do it in 3 months, in 1 year. We need to define the duration of the assessment, and then we need to be transparent. This assessment needs to be transparent, and again, to respond to the first question that you are identifying before conducting the hourly assessment.
Okay, thank you very much, Veronica. Do we have any questions in the room or any online? Oh, we do have some online. A big audience online. Let me run across the room. Just one question. Oh, yes. So this is from Duska Dimovic. How is the climate change issue addressed in the red list of ecosystems?
Mm-hmm. I mentioned previously, when evaluating criterion E is where climate change can be, for example, used to identify different scenarios. And also in criterion C, if I'm wrong, you can identify which are the variables the abiotic variables that are affecting the ecosystem. And climate change could be a main factor modifying these variables. So, for example, we can say, the hydrology. We are focusing on a mangrove ecosystem and the change in the hydrology. So, climate change could be one of the main factors affecting this variable.
Hello, I'm Ravi from the Environment Agency Abu Dhabi. All right. So I have a few questions about the tools that you have developed.
Mm-hmm.
What if we have all the data elements ready? Can we automate the whole process of doing the ecosystem assessment, including the criteria as well? Or do you need an expert knowing about the whole habitat to be able to make the final decision? Can we make some recommendations by automating the whole process? Or does it have to be a manual approach with the subject matter expert looking at each and every step and coming up with the final assessment based on the criteria?
This is a very good question. I will suggest really to contact and from the beginning to contact the right expert to describe properly the ecosystem and to define the units. And I will also suggest to have a training before. You can, of course, go through the methodology, but from my point of view, it's much better if you have a training to then know how to use the methodology properly. And also, of course, like if you are contacting the right expert, so you will have a better idea of what is going on in the ecosystem.
And another question. They're coming. Oh, sorry. Was that? Did I answer your question? Sorry, they're coming in live. So this is from Ghazala Khan. I have done similar studies identifying environmental damage. How could I get involved with the process to help others with my research study, the methodology behind ARLI?
What she can do is she can join the CM. I said before, she just need to go through the CM website, the Commission of Ecosystem Management, and then join the list of ecosystem thematic.
Yeah, it's quite a simple process.
Yeah, it's very simple,
I believe, and even if you're not part of CEM, you can still work with us on Red List Ecosystems. Yes.
Yes.
But we recommend joining CEM, of course.
Yeah.
Anything else online? Another one. Oh, no, they say they're already a member of CEM, so.
Okay, so maybe she can contact us.
To recommend to get in touch actually then with me or Veronica.
Exact.
And we can put you in touch with the right person.
And we can discuss further. Again, another.
This is a lot of running back and forth between me and the computer. This is from Xavier Benedict. We are an NGO based at Pulicat Lagoon in India. Would it be possible to get the lagoon assessed?
Would it be possible? Yes. John Paul say yes to everything. Yes. Yeah.
So what would be the first step for Xavier Benedict?
So the first step will be to identify which are the ecosystem. In that case, I don't know, it is a wetland, but that is surrounded by other, I guess, other ecosystem. And I don't know if he wants to also assess the ecosystem embed in the wetland itself. And then he will need to define which are the limits, the ecological limit of the ecosystem. And then, of course, to do a conceptual model. If it is very target ecosystem, it would be easier to develop the conceptual model and identify which are the variables.
And should he do that before? So it was also about IUCN support.
Mhm.
Does he need to do that work before approaching us, or is it better to just contact IUCN from the very beginning?
It could be both. It could be both. So approaching us without the information, but it could be much better approaching us with more information and with more background to help her or him.
And we will share the slides with the contact details as well. But you can find Veronica Ruiz at the Global Ecosystem Management Program at IUCN.
Yeah, I don't know if Davey, we can share your slide because it's some work ongoing work. Okay.
I'm not sure David heard us there, but we'll check with David regarding the slides because that's still some ongoing work. And also a big thank you for David, who's joining us from Perth. It's quite late there. So actually, David, are you heading off soon? Or are you with us for much longer?
I can stay a little longer. I'm sorry, I did get that request about the slides, and yes, we can make them available.
Brilliant. That's very exciting.
Perfect.
One more question online, running back to the computer. Brilliant. So this is also from Ghazala Khan. They very humbly ask for a holistic approach from IUCN, and they'd like to see more representation of people from developing nations partaking in red-listed ecosystems. That's something that other people have brought up where about the distribution of RLE and where it's already been done.
Yeah, I totally agree with her. Yeah.
Okay. Anything else? Any more online questions, please, right now? But I think we can move on to applications. And of course, if anybody has any questions for Veronica or David, while he's still here, or Jean-Paul, then we can come back.
Jean-Paul as well can respond to the question.
Okay.
One more. Okay.
Oh, a lot of running. Can an assessment, sorry, this is from Faiz Ul Hasnain. Can an assessment have an impact on environmental policies of a country through the United Nations? I'll repeat it for you. So can a red list of ecosystems assessment have impact on policies, so country policies that are also connected with the policies with the United Nations?
Yeah, it's what I mentioned in previous slide. The RLE methodology can inform national commitments as the SDG target or the HT targets from the CBD.
And actually, I'm going to speak now about the applications a bit more. So this is a perfect time to change over. And please hold your questions. Well, you can ask me about applications during the presentation.
I will.
But we'll have more questions at the end. Okay. So applications. Okay, so we have all of these assessments. These are the ones that we have published online that you can go and look at what we've done so far. Actually, we've done a lot more than what's online. It's lodged in the database. But what are they being used for already? We're assessing and monitoring the status of the world ecosystems, but why? We want to finish these global ecosystem assessments, but why? What are they going to be used for? How are they actually going to benefit people and the environment, and not just some targets as well? And so just for a quick recap, and I won't go through all of them, but the output, just to remind you what the physical outputs of a red list of ecosystems are. Veronica already showed the publications. You'll also get a lot of what comes out. A lot of the parts of a red list of ecosystems can also be used elsewhere. So that conceptual model is something that's very valuable to other research as well. Your diagnosis of threats, you're looking at ecological variables, and there's a lot of spatial data, the actual just gathering process of the data and making it available. We're sitting here across from the UN data forum over there, and that's what they're talking about. The data already might be out there for loads of RLE assessments, but the RLE has value in just gathering that as well. And of course, you will get a risk assessment, whether it's collapsed or threatened, and also some identification of major factors for management strategies, and also the typology behind it will keep being developed. And so you've seen this before from Veronica, and she talked a little bit about the SDGs, and there is a lot of different ways that you could look at the way that RLE gets applied. And you can have national legislation. We are actually talking also with the private sector in how this could be useful, or they can be part of the process of helping getting it funded. And there's also a part in the environmental education. I talk about Colombia later. Well, Angela Andrade is doing some excellent environmental education in South America, and she's the head of our CEM group. So there are many reasons why to do it. We've heard them before. We've talked about them before. But and these are the ones when it comes to reporting that we're interested in. Because maybe something we haven't talked about so much, because we cut down this session to make sure everybody can get their bus, is also the monitoring approach. So once you have your red list of ecosystems assessment, you can keep doing it. You can check up on your ecosystem over different years, and it can be part of larger plans. So just to touch on Australia, where David's joining us from, you actually, when you do a red list of ecosystems, even if you haven't completed the whole thing, even if you've just done the first 2 criteria, you can already start using it to talk to your governments, to open up dialogue. And so Australia has had, for example, some success in using it for management, in bushfire strategies, or in code of practices when it comes to fire. They've also used it for influencing funding priorities, both at the government level, and then also in legislation when they're looking at land zones with permission rights. And so that's we do have a lot of progress in Australia because we have a lot of our experts coming from there. And now I'm just going to show a different way of thinking about the applications. So it's not just about separating out these applications. When you do an RLE assessment, when you ask, but why am I doing this? It might be more of a strategic assessment, where you're looking already at your ecosystem, you know a lot about it, and you're looking into the adaptive management and evaluating your ecosystem. Or it might be more of a systemic assessment, which has a whole umbrella of uses, also for reporting, as I mentioned, and also for regulatory assessment. And we're really looking into how it'll affect investment priorities in regions. And I'm going to concentrate on the protected area applications in Colombia, because we've seen these. So in Colombia, there was a red list of ecosystem assessment with over 1 million kilometers squared, 80 ecosystem types identified. And they found that about 50% of the ecosystems that they identified were at risk. But the big take-home message is, and I know this is a lot of numbers, but if you look at here, this here, I don't know, oh, you can't see my mouse. In the protected extension area, that's how much of those ecosystems is covered, should maybe be protected. But the current protection is actually, 1.5%, for example, of critically endangered ecosystems in Colombia are actually under protected areas. And so that's something that came as a big, maybe not a large surprise, but it informed a lot of the decisions about developing those protected areas further. And thank you for Angela, also Andrade, for some of these slides. And so that informed some strategic conservation in Colombia, as I said, just in identifying which were the priority areas for conservation that weren't included in that protected area. And also here's also another link to climate change, because their climate change strategy also involved protected areas under the application of criteria C. Okay, so now we're going to do a short interactive exercise to see maybe what you think you could use red list of ecosystems for. And this includes online, which we have a large audience online, so we'll see how this goes. I believe everyone here has an internet connected device. If you could head to this link and type it in, you won't be asked to sign in or give any details. There'll be 2 questions for you. One just for us to find out who our audience is in terms of your background. And the other one will just be about, what do you think you could use a red list of ecosystems assessment for? This could be really specific. I forget their name, but if you had a red list of ecosystems assessment for that lagoon, what could you use that for? If you had it for the Mediterranean region, if you had multiple ecosystems assessed in the Mediterranean region, would you use that to approach your local government? Or maybe you are already representing government. Would it inform protected areas? Just some examples. And then we will be able to put up live the answers on the screen. So I will give you 5 minutes. A little bit more. Okay. And if you're in the room, you can talk to your neighbor. Some of you are lucky enough to be sitting next to Jean-Paul, so he can give you some really good tips. Okay, I will give you 7 minutes, and then we'll look at some of the responses that we get back. And just for an idea of who's answering the survey at the moment, we've got about 30% of people working in policy, few people working in NGOs. We've got a good representation from IGOs. I can imagine where most of those people come from. We've got a lot of IUCN colleagues also phoning in. 8% from government, and also quite a few, 25% spatial analysts. Okay, how much more time do we have? 6:25. Okay.
We have still 5 minutes
Ooh.
to wrap up.
So yeah, so you have 3 more minutes to write your responses, please, and then we'll put them up on the slide. No. Okay, yeah. Yes, I have it here. We've got 20 servers underway. And
20?
Yep.
There's
Nice.
60 people online, so maybe we can expect a little bit more responses.
Okay. So I think everybody's used that link now. So we're going to just change over. And so while you're writing, we're going to see a little bit of what people are writing. So could we change to my computer screen now? Oh, we have some 4% from the private sector. I feel like I'm running an auction. But policy is winning by the moment. But also some science communicators out there. Oh, well, that is, for this experiment, a lesson learned on our side. Do not use the free version of Poll Everywhere. You should definitely pay for the Poll Everywhere poll. And so, okay, thank you. For anyone who's unfortunately written and not been able to submit, please email them in to us because we would love to hear them. And I apologize for that. Would it be possible to put this screen, my computer's? Oh, no, sorry, not the slides, the Chrome.
But is someone here who couldn't go through the survey?
Yes.
That want to give your point of view or your example here?
We can identify new areas to protect and relook at the future urban development plans that have been already made. They should take into consideration the ecosystem and the holistic assessment, certainly. That way we can protect the critical habitats even better.
And which is your field expertise?
I work as an environmental data manager at the Environment Agency Abu Dhabi.
Okay. Thank you so much. Yeah.
But please go ahead in the back.
Okay, so this seems to me to be very relevant to the process of impact assessment, particularly with respect to the International Finance Corporation Performance Standard 6 on biodiversity. And potentially there is a conversation to be had between IFC and this process to incorporate it into the new version of the performance standard, because currently biodiversity management in terms of habitat management is related to critical habitats and natural habitats. And I think this would add a third category of endangered habitats or something like that, which then financiers of projects would have to take some additional management action on.
And sorry, could you introduce yourself and give us your background?
My name is Simon Wilson. I work for a company called 5 Oceans Environmental Services. I'm a marine biologist and sort of impact assessment practitioner.
Thank you.
Where exactly? I'm based in Muscat in Oman.
Brilliant. We have another one in the room, and then we'll go on to some online as well.
So I answered the poll, but maybe I just have a comment. And, on the application side, first of all, I think RLE's totally the way to go. It's a smart, the way you're putting it together in a methodical way is the right way to go. Now, just like with red listing species, the devil's always in the details in terms of how people apply this. So I'm from Canada. I used to run a species at risk program. Our funding model was if it's the more at risk it is, the more funding it gets. We never were allowed to look at, is it a hopeless case? You know, so how about keeping common species common or being more proactive? And the same would apply with RLE in that with your application side, providing some context of what are the drivers of that risk and whether we actually have any ability to turn that around, because I think a lot of times we don't, or we have limited abilities. So having some guidance for policymakers on how best to apply this is really important, because it still blows me away how even sort of environmental ministries in my country just sort of blindly say, oh no, this is how we're going to spend the money, and there's not a cost benefit analysis that's part of that. So I think that would be really useful to provide that guidance.
Okay, brilliant.
Thanks so much. It's not the first time that someone give us this recommendation. Thanks so much.
It's something we think about a lot,
Yeah.
actually, and we hope
Exactly.
to learn from our Red List of Threatened Species colleagues as well.
Yeah, that's a really key point, and that's something that you look at the Red List of Certain Species literature, and there's always a clear distinction between risk assessment, which is assigning the category, and priority setting, which is taking that category and deciding what you do with it. And even though it is very clear that those are two separate processes, it's very rare that people apply it that way. And that's something that we have emphasized from the beginning. And the idea of the conceptual diagrams of the ecosystems is precisely that, is to see, you know, where the key intervention point is, and then that way you can assess the cost or whatever.
Okay, so before we take anything else in the room, I'm just gonna, or well, we can wait while this loads, but we can look at some of the, here they come, oh, they come up slowly.
Okay, there is some question online. Maybe we can go through. First is from Abraham Ekperusi. Ekperusi. I attended a conference last 2 weeks where someone from the biodiversity unit of Shell Nigeria said they are working with IUCN to review their operation in Nigeria. I would like to know the level of engagement with Shell Nigeria and how this can help reduce environmental impacts and ecosystem threat in the Niger Delta ecosystem. To respond properly to this question, I will better be in contact with my colleague for the Business and Biodiversity program, because I guess they were the person who attend this event who attend this event. I will prefer to maybe to keep in contact with you, Abraham. If you can provide us your email, then I will respond to your question as soon as possible. And second is Duska Dimovic, and this is not a question, but she wanted to provide her input on the survey. Thanks so much, Duska. She comes from the policy sector, and her work is focused on the protection of freshwater ecosystem and protected areas, physical planning work with corporate sector. And Eleonora also wanted to provide her a vision and her input, and then she agreed with Simon.
Sorry. That sounds great. And the link to the Business and Biodiversity team, actually, we had a business week recently at IUCN where we presented a red list of ecosystems at there in collaboration with the Business and Biodiversity team. So if there are private businesses interested, we work with the Business and Biodiversity team to have conversations with them.
We work jointly with them because they are the custodian of all related with the private sector.
Yeah. So yes, if you couldn't do the survey, but we'll go through a few on the screen before we go. And also, I'm mindful of the time. I don't want to run any much more over. So what I've seen from quickly reading is that we have quite a few. We had a few about protected areas, about bringing it to policymakers in their area, and also quite a few mentions also of management. But one thing that's coming up over and over again is certain regions. People asking, why hasn't this been done here? My first point would be, maybe it has. On our website, we have the public list of red list of ecosystems at the moment, but in our database, we have a lot more ongoing and completed, but maybe not published yet. And the second would be, yes, our aim, as Jean-Paul said, is to get this done globally for all ecosystems. So if you have a will and an interest And if you have data, great, get in touch with us when we share this slide. And yes, and I think Jean-Paul will give us a final word.
No, David, do you
yes.
a final word before you fall asleep?
For policy, I think the Red List of Ecosystems has great potential in a whole range of different areas, from very, very local changes in ecosystem management and helping us to develop strategies, through to national policy and legislative frameworks, where a number of countries are already using red listed ecosystems to make decisions about where they put their protected areas, how they regulate major projects, and those kinds of large sort of social and economic decision-making problems.
And maybe to wrap up, I really want to thank Jean-Paul for the opening session. Thanks so much. And thank you so much, David, for joining us remotely and for presenting your incredible work on the global typology. Thanks so much.
And thank you to Ion Earth, of which we're a member. Oh, we have another question, but we'll keep rolling with the thank yous. Thank you for our audience, both online and in the room, to Ion Earth and to Dubai also for hosting us at the moment, and for Veronica for putting together a great session. But she's got one more question for me, or for us.
It's not a question, it's more a comment. It's a very good comment. I will be best, is Ghazala Khan, who said it would be best if IUCN established a data bank for the similar studies and invite those having similar work done for further elaboration and sharing this experience with IUCN. This is a very good idea to compiling all the similar studies, but as I said, we are developing the IUCN RLE database, and we are compiling all the assessments that have been done using the criteria. So we need to compile all the assessments that have been done and using the same framework. That's where we are promoting the use of the RLE methodology. Of course, it's very important to compile all the information about assessment done on ecosystem, etc. But in that case, what we are doing is developing our own database, but with the assessment that have been using this criteria. And then also it is important, this talking about this database that is coming quite by the end of the year, I hope, and we will still working on next year. It will be a database who will be connected with other IUCN knowledge products. For example, it will be connected with the IUCN Red List of threatened species, with the database of the protected areas, but also with the IBAT. IBAT is a tool that can be used for the private sector, and it is a tool that also compiles all the data generated by IUCN. But of course, it will be very important also to have this data bank with all the evaluation, assessment of ecosystem.
And maybe just to build on that, also the data, it's great being here at the same time as the UN Data Forum, because the data behind other assessments can also be collated. If you know the other assessments that have been done, maybe you have an idea of what data there is in your region, which means the very first part, the pre-assessment, pre-concept for your red list of ecosystems might be easier because the data might already be there. So those are very important people to talk to, is people who've already done assessments in your region.
Whether NGOs or personal, I mean, whether the private sectors or even the government also can really help. There is like access to the database, because I'm sure if you go to any municipal, they would have a database.
That's a great point. Actually, we were just talking about the main benefit for us from the Ion Earth Symposium was coming here and meeting such a varied crowd, because we were thinking actually when we do a red list of ecosystems somewhere, to know who, really to get an idea of all of the data that everyone has amassed in that region. So absolutely, NGOs, governments, you get the data, high quality data where you can find it. And I'm afraid the people in the room need to get to their bus, otherwise they're going to be stuck here for a while. So we're going to have to finish this session for today. So thank you very much again for listening, and thank you, David, for staying up with us.